In previous session, we discussed that we have zero sequence current from the NCT or core balance transformer, current transformer. We connect it to the relay, and relay before using that value in the functions, relay does some of the compensation that is called angle error compensation, and then that component is used as a zero sequence component for further using of the function. Why this angle error compensation is required, we already discussed, but let's have a review on it. Suppose in the normal system we have a 3 zero sequence current like this, but due to this, we know that we measure this 3I0 from core balance transformer, and this value may be deviated to some angle. It's very minor angle, but I draw it a little higher for more clarification and for visualization. This is our 3I0 measured value here. Why this deviation in the angle occur? Why this deviation angle occur? This is because here in our system, when 3 phases goes inside of the core balance transformer, here we have some air gaps. So due to these air gaps in the core balance transformer, we will have some deviation angle of zero sequence current which is measured. Or maybe due to our system configuration, here our system be like not directly grounded. It maybe our system is grounded by a coil, and this coil, as for example our system is resonant grounded coil is used. So due to this resonant grounding coil, during the fault, a very high reactive power factor will be present in the system. So our active power factor reduces much. Due to this reduction of real power factor and due to increase of reactive power factor, I recall it as PFR, it increases due to this increment of the imaginary part of power factor or the reactive power factor. This deviation angle will occur. Now the question will be in your mind that how much this angle will deviate, how much will be this deviation angle, and how much we should enter to the relay understand that this amount of angle is the deviation angle and the error angle. So for example, here we have our core balance transformer installed, and we don't know that how much angle we should enter in the setting of this relay, this relay understand that, okay, this amount of deviation angle due to the air gap or our system configuration will be present. Here in our system, before connecting these wires from the core balance transformer to the relay, instead of the relay, we use a power analyzer. It is power analyzer. We connect this power analyzer, and also we know that this power analyzer should be connected to the phases also through the CTs, phase CTs, and we should make sure that our actual burden should be installed in the system by the time that the actual burden is installed, and we connect this power analyzer, and that time we apply a current of, for example, current I1. Due to this going to current I1 in this three phases, we take this I1 value of, for example, 0.5 amperes in secondary, and we watch and we see that how much will be the deviation of the angle. Maybe we take it as alpha 1 as some values, for example, 2 degrees. Then we increase this value of the current. For example, we take it very higher. Current I2, we supply I2. And due to this I2, for example, this is I2 in the primary, of course. And these are the I1 and I2 in the secondary. And we see that this I2, for example, we have rated current in the primary, so the secondary side will have 1 ampere. And due to this 1 ampere in the secondary, we calculate alpha 2, or the deviation of this angle. We see this from power analyzer. As for example, some angles, like it is lower, 1 degree. Then we apply these values into our relay. We apply these values into the relay, and relay after that will understand how much this angle, deviation angle, should be compensated, the deviation angle of this covalence current transformer. This is in the graph that here we mention the angle error at the current of I1, the amplitude of current I1, and at current 2, this is the angle error, the deviation angle. Then the relay will understand, due to the by this graph, the relay will understand how much should be the deviation angle in different currents into the secondary of relay, and it will compensate. This is what I meant, that this current is supplied, and we should enter the value of the covalence current I1 and the angle error due to that I1 and I2 value, and the angle error due to that I2. At the output of this is what the angle error compensation does for us, and it gives the compensated zero sequence current for the operation of relay. Please follow us and subscribe our channel, because we will discuss for next lectures and sessions. We will discuss how these components works, angle determination, how the angle is determined, and how the fault extension is detected, and how much should be the decay of time for the detection of the fault extension, and all these components and the blocks.